The subject of this video is commissioning the ratio control configuration that uses the characterization function. The characterization function relates the fresh air damper opening to the fuel gas valve opening. To display this characterization function, left-click the TY element on the graphic display to open the point window for the characterization function. From the point window, switch the mode to manual. Then open the configuration window. The relationship for the characterization function is on the Function tab. The relationship is clearly nonlinear. Characterization functions are defined by specifying individual points. These are indicated by circles on the graph. The coordinates for the points can be displayed using the first and next buttons. One of the points corresponds to the normal operating conditions, specifically 82.5% for the fuel gas valve opening and 61.8% for the fresh air damper opening. For a fuel gas valve opening of 30% or less, the characterization function is a horizontal straight line. To prevent firing rates below minimum fire, a value of 30% is specified for the lower output limit for the scrubber duct inlet temperature controller. Consequently, fuel gas valve openings less than 30% should never occur. But should they occur, the output of the characterization function will be the fresh air damper opening that corresponds to a fuel gas valve opening of 30%. Close the configuration window for the characterization function by clicking the Cancel button. Then change the mode to automatic. We have not yet tuned the scrubber duct inlet temperature controller, nor have we tuned the hot air temperature controller that provides the trim for the characterization function. Before either loop can be commissioned and tuned, we need to verify that the performance of the characterization function is acceptable. Neither controller is on automatic, but the characterization function is doing its thing. If we change the opening of the fuel gas valve, the characterization function will change the opening of the fresh air damper. Increase the opening of the fuel gas valve from 82.5 to 86%. The output of the characterization function changes from 61.9 to 68.9%. After applying the feedback trim of minus 0.1%, the fresh air damper opening is 68.8%. The expectation is that the hot air temperature would remain near 210 degrees Celsius. Instead, the hot air temperature increases to 217 degrees Celsius. Superficially, the characterization function appears to be significantly in error. At the moment, no control is provided for the hot air pressure. Opening the fresh air damper caused the hot air pressure to increase from 2.5 to 3.05 millimeters of mercury. This pressure increase reduces the pressure drop across the fresh air damper. Consequently, the fresh air flow is less than expected. The lower fresh air flow definitely contributes to the increase in the hot air temperature. To maintain a constant hot air pressure, any change in the opening of the fresh air damper must be accompanied by a change in the opening of either or both of the hot air dampers. One possibility is to develop additional characterization functions that relate the hot air damper openings to the fresh air damper opening. The alternative is to provide a control loop for the hot air pressure. As the hot air pressure responds very rapidly, a control loop is the preferred approach. We shall propose one in a subsequent video. Controllers that provide a feedback trim are normally tuned to respond slowly. That means a low controller gain and a long reset time. Performance criteria such as quarter decay are never appropriate. The assumption is that the characterization function will provide most of the required control action. Consequently, the feedback trim controller is expected to have little work to do. As a hot air temperature controller is currently tuned, the controller gain is 1 and the reset time is 3 minutes. For temperature loops, a controller gain of 1 is a low value. The reset time of 3 minutes is long with respect to the dynamics of the furnace. Switch the hot air temperature controller to auto. The controller slowly increases the feedback trim, which opens the fresh air damper and lowers the hot air temperature. A side effect is that the hot air pressure increases, which causes the characterization function to be even more in error. The hot air temperature controller responds slowly, but given sufficient time, it will increase the feedback trim until the hot air temperature is 210 degrees Celsius. The next video will propose control configurations for both the hot air pressure and the baghouse inlet temperature.